We're done talking about the specifics of the two systems, the histogram and the box whisker plot. Now we're comparing the two, and we're going to compare this concept of resistant versus non-resistant. Let's get an example, which is about polar bears. A polar bear is fitted with a radio collar, which is able to track its position. The distance traveled each day is then recorded. Right? Some of these distances are really quite large. It's in kilometers. I totally made these numbers up, so I have no idea if they're actually accurate. But let's make our two systems, our histogram and our box whisker plot. And using one of our stats, I can get my center and spread for both. And really what I want to do is ask the question, if the next day the polar bear travels a distance of 71.4, what effect does that have on the center and spread? I can plug that in. Notice down here, I plugged in my 71.4, reran one of our stats, and here I have the mean, changed a little bit, not too much. Standard deviation changed a little bit, not too much. Median, not a big change. IQR, no change at all. Right? And that kind of makes sense because 71.4 is kind of in the middle. It's probably not going to throw things around too much regardless. So now, if I don't use 71.4, I'm kind of experimenting here. I'm testing. What happens if it actually traveled quite a long distance, 235 kilometers, and notice down here I plugged that into my data and I reran my one var stats, and now this extreme value is, and like 235 is like way out here on the scale. So this is now a very unusual value. It might be an outlier, likely I suppose. All right, and so now we have a fair difference between the new mean and the old mean. Right, the spread fair difference, but notice over here. We have a difference, but not so much. Right? We have, again, the spread difference, not so much. So we're getting a difference of behavior here. Let's make this a little bit more extreme to see if we can tease out that difference of behavior. Instead of 235 kilometers, maybe let's go 500 kilometers. Right? And down here we can see we have 500. And now what happens to the mean, right? It keeps going up. Now it's at 70, started off at 54. The spread is now going up a lot. Notice over here, right? It actually didn't change at all from the 235, right? Neither of them changed. It's really not moving at all. Right? So this is actually the underlying concept of resistant versus non-resistant. If you were to guess which one would be resistant, you might guess, hopefully, that it's the box whisker system, right? Because we have these sort of big extreme value of like 500, and our measures of center and spread, not affected all that much. It can resist the influences of such an extreme value, while in the not the box whisker, the histogram system, it gets thrown around, which means, of course, that's the non-resistant system. Now, which one is better is maybe a question, and of course that's not really a question. It's just which one do you use under what conditions? If you don't think you have any outliers, really either one is equally valid. Now, if you do have outliers, some extreme values, then you have a decision to make. You have to decide how much influence do I want those to have on my measures. If the answer is you don't want them to have a lot of influence, then you probably should use the median IQR box whisker system. If it's reasonable, if you want all the values, including outliers, to have an impact, well, then you might want the histogram mean and standard deviation system. It's just a matter of choice and being intentional.